Okay, in the first lesson, we were talking about radioactive elements. And as I explained in the first lesson, that radioactive elements are either atoms having high number of protons or radioactive elements. These elements get out the extra energy in the form of radiation. We measure this radiation by something called Geiger counter or scintillation counter. Okay, the most important question now. How do I know which element releases which kind of radiation? Actually, it's something that I observe it. I will get the counter and I will get the radioactive element and I will just observe. Sometimes an element can get out only one kind of radiation, others can get out two kinds of radiations, and so on, till what? Till the element becomes stable. Okay, what we're going to take today are examples of these radiations. As you see here in general, that atom X, whatever the radioactive element is, begins to release energy. When it releases an energy, it gets out particles with it. And this element changes into another element. Let us see an example here to make things more obvious. Alpha decay. This is the first kind of radiation that we're going to work on it. Alpha decay, its symbol like this, as you see, or helium-2, 4. What's helium? This means that all this radiation consists of helium particles. Okay. Let us see here an example. An element like this, uranium-92 atomic number, mass number 238. When this element gets out alpha particle, what happens? As you see here, when it gets out alpha particle, which is helium particle, what happens here to the atomic number? The atomic number here decreases by 2, so 92 becomes 90. And the mass number here decreases by 4, so 238 here becomes 234. All what I'm going to see that I will search the element that has 90 as an atomic number in the periodic table. Okay, I will find that its name is thorium. Of course, I will not search for the element with its mass number because I may have more than one element having the same mass number, or the mass number can change. And for example, uranium 9238, I have another uranium 92235, its mass can change. Okay, so I search the element in the periodic table with its atomic number. So as you see here, when uranium gets out alpha particle, the new element changes, that its atomic number decreases by 2 and the mass number decreases by 4, and the element, of course, completely change into a new element. And by the way, this is the way we create artificial elements from radioactive elements. Okay, so let us see here. Each alpha particle consists of 2 protons and 2 neutrons. As you see here, helium, its atomic number is 2. This means that the protons equals 2. And neutrons, we do the mass number minus the atomic number, so 4 minus 2. This means it has 2 neutrons. The net charge inside the nucleus at the end is positive 2. Okay, why? Because the protons are positive charge and the neutrons are neutral, so the net charge is positive. So the first thing I have to know that alpha particle is helium particle. Each alpha particle consists of 2 protons and 2 neutrons, which has a double positive charge. This means that the whole radiation consists of positive particles. The third thing I have to know, as you see here, that the atomic number decreases by 2 and the mass number decreases by 4. And the original radioactive element changes into another element. One of 2 cases may happen here. Sometimes the element becomes stable when it gets out the radiation. And in this case, the atom will not get out more energy, or the element formed still, it's a radioactive element, so it will get out more and more radiations of different kinds till it becomes stable. Another thing I need to know about alpha radiation, that it do not travel very far and has low penetrating power because of their mass and charge. What does this mean? When the radiation has both heavy mass and charge, we say that it has a low penetration power. So when the radiation consists of heavy particles, what's meant by heavy particles? This means here in helium, its mass number is 4, so each ray consists of many and many and many alpha particles, consists of many helium particles. Each helium particle, its mass is 4 atomic mass units, so it's considered to be heavy. And at the same time, it has a charge. So both of them, both the mass and the charge, make the alpha radiation has a low penetration power. The mass, of course, when something has high mass, so it cannot penetrate something easy. And when something has charge, it can be disturbed by anything on its way. For example, when the positive charge meets anything on its way, a negative, so it gets attracted to it. When it meets anything, for example, as a positive, so it begins to repel. All of these factors begin to make the radiation has low penetrating power. It cannot go far apart. Of course, when the radiation has low penetrating power, it becomes less dangerous because it cannot penetrate the body easily. When the radiation, of course, penetrates the body, it may cause cancer, diseases, and so on. But the alpha radiation, as it has low penetrating power, so it cannot penetrate our bodies, so it's not dangerous. So as you see here, A sheet of paper or the skin can stop alpha particle only. So it's not dangerous. يعني, I mean, or even a paper or a sheet of paper can stop alpha particle. This means that it's not dangerous. It's dangerous in one way only when ingested, when it's taken in doses, in great doses in medicine for patients, for example, taking cancer and so on, because when ingested, it's found direct inside the body. Okay, let us sum up here. Alpha radiation again. Alpha radiation, any kind of radiation. First, it's measured by Geiger counter or scintillation counter. Any kind of radiation, what does it do to the element? It changes the element into another element. The element start to get out the extra energy until what? Until the element changes into a stable element. As we said, it can get out 1, 2, or 3 kinds of radiation until it becomes stable. The first kind is alpha decay. Alpha, its symbol is, as you see here, or helium. This means that each radiation consists of many and many helium particles. Each alpha particle consists of 2 protons and 2 neutrons. So the net charge of this radiation is positive. The third thing, the atomic number, as you see here, when this radioactive element begins to get out alpha radiation, what happens? Atomic number decreases by 2 and mass number decreases by 4. Alpha radiation is not dangerous. Why? Because it has low penetrating power. And why it has low penetrating power? Because it has charge and mass. Okay, let me tell you something very important so you can understand the rest of the radiations about penetration power. If something has high penetration power, so it has no mass and no charge. If something has moderate penetration power, so it may have one of the two things, mass or charge. If something has low penetration power, so it has both mass and charge. That's why alpha radiation has both mass and charge. So it has low penetration power. When something has low penetration power, it becomes less dangerous, as a sheet of paper or a skin can stop these radiations. Okay, thank you so much.